Today's topic is measures of dispersion, chapter 6. What is dispersion? Dispersion refers to the variation of the items around an average. According to Dr. Bowley, dispersion is the measure of the variations of the items. Define dispersion according to Dr. Bowley. Bowley. What are the uses of dispersion? First point, to determine the reliability of an average. Reliability. Second point, to compare the variability of two or more series. Thirdly, to provide the basis of other statistical measures such as correlation. Fourthly, to provide the basis of statistical quality control. What are the essential features of a good measure of dispersion? That is, it should be easy to understand. Secondly, simple to calculate. It should be uniquely defined. It should be based on all observations. It should not be unduly affected by extreme items. Should not be unduly affected by extreme items. Measures of dispersion may be either absolute or relative. Absolute measures of dispersion are expressed in the same units in which data of the series are expressed, that is rupees, kilograms, tons, etc. Whereas relative measures of dispersion are independent of the units of measurement and they are expressed in percentages. These are used to compare two or more series which are expressed in different units. Now we can study which are the absolute measures of dispersion. The first one is range, R-A-N-G-E. The second one is quartile deviation. Third one is mean deviation. Fourth one is standard deviation. Fifth one is Lorentz curve. Lorentz curve is a graphic method of studying dispersion. We can study one by one. The absolute measures of dispersion are, which are the coefficient of rate, coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation, and fifth one is coefficient of variation. Coefficient of standard deviation, fifth one is coefficient of variation. So the next question is, what is range? Range is the simplest one, simplest measure dispersion, and it is the difference between largest and smallest value of the distribution. Largest item minus smallest item. Range equal to L minus S. That's absolute measure dispersion. If it is a coefficient of range, that is a relative measure dispersion, the formula is L minus S as the range formula itself first at the top divided by L plus S. Absolute measure dispersion, coefficient of range, L minus S same as numerator and divided by L plus S. What are the merits of range? Range is simple to understand and easy to calculate, and it is widely used in statistical quality control, and there are many uses. Meanwhile, what are the demerits of range? It's affected by extreme values in the series. It cannot be calculated in the case of opponent series, and it is not based on all the items of the series. The second measure of dispersion, that is quartile deviation. In order to understand quartile deviation, first of all we have to learn what are quartiles. Median is a positional average and it divides a series into two equal halves. So what are quartiles? Quartiles are the measures which divide the data into four equal parts. Four equal parts. Each part contains equal number of observations. So when we draw a line, there's four parts. Q2 is the middle value, that is a median. There's Q1, Q2 and Q3. It should be equal parts. So there are three quartiles. When a line or a segment or a series divided into four equal parts, first one is Q1, second one is Q2, that is same as median. Third one is Q3. So there are three quartiles which are the Q1, Q2 and Q3. The first quartile is denoted by Q1. It's a lower quartile and 25% of the items of the distribution are below to it and 75% of the items are greater than it. The second quartile is denoted by Q2. It's called median. It has 50% of the items below it and 50% of the items above to it. The third quartile is denoted by Q3. It's called upper quartile, and 75% of the items are below and 25% of the items are above it. Thus, Q1 and Q3 denote the two limits within which central 50% of items lie. Like that, we have another concept. We heard about percentages, like that percentiles. Percentiles divide the series into 100 equal parts. For any series, there are 99 percentiles, denoted by P1, P2, P3, P99. P50 is the median value. If anyone secures 85 percentile in examination, it means that his position is below 15% of the total candidates appeared in the examination. So, in the case of quartile deviation, first of all, we can have interquartile range. Interquartile range and quartile deviation are another measures of dispersion. Interquartile range IQR is the difference between the upper quartile is called as Q3 and the lower quartile is Q1. So Q3 minus Q1. Meanwhile, quartile deviation is half of the difference between the upper quartile Q3 and the lower quartile Q1, that is half of the interquartile range. Coefficient of quartile deviation, that is a relative measure of quartile deviation, is coefficient of QD. QD stands for quartile deviation. So as numerator, same Q3 minus Q1 divided by Q3 plus Q1. Put this formula in the bubbles and learn thoroughly. What are the merits of quartile deviation? Easy to compute. It can be computed in open-ended series also. It is less affected by extreme items. Demerits, we can understand it ignores half, that is 50% of the items, and it is not based on all observations. So calculation of quartiles. In the case of median, it's a n by 2th item. So in this case, series is divided into 4 equal parts. So Q1 is equal to size of n plus 1 by, instead of 2 we have to write 4 Q1. Yes, this is one part, 1 by 4th, that is Q1, that is 25%. Q3 is 75%, size of 3 into n plus 1 by 4th item, because 75%, isn't it? Then how do we calculate interquartile range? Interquartile range IQR is equal to Q3 minus Q1. Find out Q3 using this formula, in the case individual series, and Q1 using this formula, and difference between these two, isn't it? And quartile deviation is equal to Q3 minus Q1 divided by 2. Apply the formula, learn the formula thoroughly. Okay.